Python. Created by Guido van Rossum in the late 1980s and released in 1991, Python was designed to make code easy to read and write. Its syntax relies on indentation rather than symbols, which forces a clean structure from the start. Over the decades, it has become the default choice for beginners, but it also powers serious work in data science, artificial intelligence, and automation. What sets Python apart is its massive collection of libraries, which lets developers solve complex problems without writing everything from scratch. Companies like Google, Netflix, and Instagram rely on it for everything from back-end services to machine learning pipelines, and its gentle learning curve keeps drawing in newcomers every year. JavaScript, built in just 10 days by Brendan Eich in 1995, JavaScript was originally meant to add small interactive touches to web pages. It quickly grew far beyond that simple goal. Today, it runs inside every major browser, and through tools like Node.js, it also powers servers and back-end systems. Its biggest strength is flexibility, since the same language can build a button animation or an entire web application, which is why it remains one of the most widely used languages in the world. Nearly every website a person visits depends on it in some form, whether they notice it or not. Java. Sun Microsystems released Java in 1995 with a promise that has stuck ever since. Write once, run anywhere. It achieves this through the Java Virtual Machine, which lets the same code run on different operating systems without changes, a feature that was groundbreaking at the time of its release. Banks, large corporations, and Android apps have relied on Java for its stability and predictable performance, especially in systems where downtime is simply not an option. It tends to require more code than newer languages, but that structure is exactly what makes it dependable for systems that cannot afford to fail. Even decades later, it remains deeply embedded in enterprise software that quietly runs in the background of daily life, powering everything from airline booking systems to insurance platforms. Its long history also means there is a vast pool of experienced developers who understand it deeply, which keeps large organizations comfortable continuing to invest in it. C. Dennis Ritchie developed C at Bell Labs in the early 1970s, and it remains one of the most influential languages ever created. It gives programmers direct control over memory and hardware, which makes it fast but also demanding to work with, since mistakes can lead to serious and hard-to-trace errors. Operating systems, including large parts of Windows and Linux, are built using C, and its influence extends into nearly every corner of modern computing. Many modern languages borrow their syntax or core ideas from it, so learning C often means understanding the foundation that much of computing rests on. Even today, embedded systems in cars, appliances, and medical devices often run on code written in C precisely because of how tightly it can be controlled and optimized. Its age has not diminished its relevance, since anything requiring maximum efficiency on limited hardware still tends to reach for it. C++. Bjarne Stroustrup extended C in the 1980s by adding object-oriented features, creating what became C++. It kept the speed and low-level control of C while introducing tools that made large, complex programs easier to organize into manageable pieces. Video games, real-time simulations, and high-performance software often rely on it, since few languages match its combination of raw speed and structural flexibility. The trade-off is a steeper learning curve, with more rules for a programmer to keep in mind, and mistakes can be just as costly as they are in C itself. Major game engines and financial trading systems still turn to C++ when milliseconds in memory truly matter, particularly in situations where even small delays can have real consequences. Its complexity has kept some developers away, but for the applications that demand absolute performance, no simpler alternative has managed to fully replace it. C#. Microsoft introduced C# in 2000 as part of its .NET platform, aiming to combine the power of C++ with the simplicity of languages like Java. It became the primary language for building Windows applications and, through the Unity engine, a major force in game development, particularly among independent studios. Its close integration with Microsoft tools makes it a natural choice for teams already working within that ecosystem, offering a balance of performance and ease of use that suits both large enterprise software and smaller creative projects. Independent game developers in particular have embraced it, since Unity has made it accessible to people without a traditional programming background, letting hobbyists build and publish real games. Over time, Microsoft has continued to modernize the language, adding features that keep it competitive with newer alternatives while maintaining the stability that businesses depend on. Swift. Apple released Swift in 2014 to replace the older Objective-C for building apps on iPhones and Macs. It was designed to be safer, catching common coding errors before they cause problems, and faster to write than its predecessor, which had grown increasingly cumbersome over the years. Since Apple actively promotes it for all new app development, Swift has become essential for anyone building software within Apple's ecosystem, and its cleaner syntax has made it more approachable for newer developers entering iOS development. It also compiles to fast fast, native code, so apps built with it tend to feel smooth and responsive on Apple hardware, matching the performance expectations Apple sets for its devices. As Apple continues to expand Swift beyond just app development, its influence within that walled ecosystem keeps growing. Go. Engineers at Google created Go, often called Golang, in 2009 to address frustrations with building large-scale software systems, particularly the slow compile times and tangled complexity common in other languages at the time. It strips away unnecessary complexity and compiles into fast, efficient programs, while also making it simple to run many tasks at once through built-in support for concurrency. Companies handling massive amounts of network traffic, including Google itself, use Go for back-end infrastructure where reliability under heavy load is essential. Its appeal lies in combining the speed of older languages with a simplicity closer to modern ones, avoiding much of the ceremony that slows developers down elsewhere. Tools like Docker and Kubernetes, which power much of modern cloud computing, were also written in Go, cementing its place at the center of how the internet's infrastructure actually runs today. Rust. Mozilla began developing Rust in 2010 to solve a long-standing problem in programming: how to get the speed of C or C++ without the memory errors that often come with them. Rust enforces strict rules at compile time that prevent many common bugs before the program ever runs, catching issues that might otherwise only appear after software has already shipped. This makes it demanding to learn at first, but developers who stick with it often find it prevents entire categories of crashes and security flaws that plague other systems languages. It has topped developer surveys for being the most loved language for several years running, a rare distinction for a language known for its steep learning curve. Companies are increasingly rewriting critical systems in it, drawn by the promise of eliminating whole classes of bugs that have caused real security breaches in the past. SQL structured query language emerged from IBM research in the early 1970s and became the standard way to communicate with databases. Unlike most languages on this list, SQL was not built to create applications, but to store, retrieve, and organize data efficiently, using a declarative style where you describe what you want rather than how to get it. Nearly every system that handles information, from banking records to social media accounts, relies on some form of SQL running behind the scenes, making it one of the most quietly essential languages in existence. Anyone working with data, regardless of their specialty, eventually runs into it, whether they are a software engineer, an analyst, or a researcher. Despite the rise of newer database technologies, SQL has proven remarkably durable, remaining the common language that connects nearly every data-driven system in use today. Every one of these languages was built to solve a different problem, yet together they quietly power almost everything we use every day, from the apps on your phone to the websites you visit. Some were built for speed, some for safety, and some just to make coding easier, but each one still shapes the technology around you in ways you rarely notice. Whichever one catches your interest, learning even a little about how it works can change the way you see the technology you rely on every day. And if you're just starting out, you don't need to master all of these at once. Pick one that fits what you want to build, and the rest will start making more sense as you go. If this helped you understand programming languages a little better, hit subscribe for more explainers like this, and drop a like if you'd want a deeper dive into any of these in the future.